In this video, I'm showing you how to deal with physics problem. So first thing when solving physics problem is find what are given and what is the target variable. Then what concept we could apply to solve that problem. If we look at this problem, what is given here, a boy pulls a box of mass 30 kg. So mass of the box is given. I can write it down here. Mass of the box denoted by m is 30 kilogram. Okay, with a force of 25 newton. Second thing is force is given, which is 25 newton in the direction as shown. So whenever the force is making certain angle with positive x-axis, we can split this vector into its component. Okay, so this is the x-axis, and right here is y-axis. Okay, so this is y-axis and this is x-axis. This is angle theta, or it is 30 degree. Okay, angle is also given, so I can write it down here, which is 30 degree with positive x-axis. Okay, we know how to split vector into its component. So x component is f cos theta, right? So I can write down like 25 cos 30 degree, and y component is f sin theta. So 25, this is the 25. Okay, so force sine of 30 degree. Okay, so this is the y component acting along the y-axis of this vector, and this is the x component acting along x-axis, so that it will be easier to deal with the forces, to get the resultant of the forces along x-axis and y-axis. Once we split into its component, it becomes easier. Okay, so look at here. Now A, ignoring a friction is absent. So if there is the friction, then some force, when you apply force in the direction of the x-axis, there is the component of this force, then there will be the frictional force opposing this force in the direction just opposite to this positive x-axis. That is, frictional force will act in the direction of negative x-axis, in this direction. Okay, so in this direction, but this is absent right now. Okay, question said that ignoring friction. So our target variable in A is what is the acceleration of the box. That is asking x acceleration is equal to what. Okay, because there is no motion in y-axis, right? This box is moving in x-axis. Okay, so this is the identification of the problem. So next step is setup. Now setup means set up an equation, so that once we set up equation, then you can solve it. So what are the forces along the x-axis? Just to look at the forces along the x-axis and sum them. Okay, add all the forces that are acting along the x-axis. If you look at this problem right here, there is only one force acting along the x-axis, which is the x component of this force, 25 Newton, right? So x component of this force is simply f cos of theta, and we know f is 25, and cos theta, cos 30 degree, right? Cos 30 degree. So now you can set off this equal to, this is equal to max. Mass of this box is m, and the acceleration along the x-axis is A. So total force is equal to, this is Newton's second law, right? F is equal to ma. Because motion is along the x-axis, we can say x-acceleration is ax. Okay. Now, next step is execute. Now we have to solve. We have to do some mathematics. Now let me do right here. So if I simplify this one, if you put into calculator, you will get something like 21.65. Let me do calculation real quick so that cos of 30 cos multiplied by 25. Yes, I'm getting 25.65 is equal to max, right? And then mass is given, so I can insert the value of m from here and get acceleration. So x acceleration is equal to 21.65 divided by mass, and ax is equal to 21.65 divided by mass is 30 kilogram. Okay, so this gives you, if you divide this one by 30, you will get something 0 0.72 meter per second squared, right? Everything is in SI system, so I don't carry units throughout my calculation, but if all the units are in SI system, we can write down unit of acceleration in meter per second squared, which is SI system. Okay, so x acceleration here, ax is 0 0.72 meter per second squared. Okay, so this is our first answer. Now let's calculate a second one. Okay, what is the normal force exerted on the body by the ground? So this object is placed on the surface, this surface, it will exert gravitation, gravity will pull it downward, and there will be upward force applied by this ground that we call normal force, right? So this is the normal force, and right here we call it the weight, right, acting downward. And as we know before, there is the y component, which is 25 sine of 30 degree, right? This was y component of the force 25 Newton acted by this boy. Okay, so as we did before, for B, we can identify, we already write it down, what is mass and what is force. I'm not rewriting again. So I will use those values for the calculation of normal force. Now, I will sum all of the forces along the y-axis. Okay, let me do it. Summation y will be equal to, what are the forces there? This is the along y-axis. That's why upward will be positive. I will take positive. So n is the positive, which is normal force. And I will take 25 sine of theta, which is also positive. And this W will be negative because it is acting downward, which is along the negative y-axis. Okay, so this is equal to 0. Why 0? Because, actually from Newton's law, F is equal to ma. Y along y-axis, if you look at here, there is no motion. So acceleration is 0. That's why it could be equated to 0. Okay, so I can rewrite like n plus 25 cos 30 degree minus w is equal to 0. So I have to find the n, so I can write it like w minus 25 cos 30 degree, right? Again, what is W? W is weight, and it is given by mass multiplied by gravity minus 25 cos 30 degree. Okay, so I know mass of this box, which is 30 kilogram. So N is equal to 30 kilogram multiplied by value of acceleration due to gravity, which is G, is 9.8 minus 25 cos 30 degree. Okay, if you calculate this value, you will get something like 281 Newton. Okay, so this is the normal force acting along y-axis. Okay, acting upward. Remember, this normal force will always acting upward. It is perpendicular to the surface on which object is kept. So this normal force is in the direction perpendicular to this surface.